Today, we're gonna find out how much time you have to wait for your Tesla to warm up its cabin. Behind me, I have two cars. One is our legacy Model 3, which was built in 2019. And next to it is its newer sibling, which is called the Highlander, which is the Model 3 Tesla started producing around the 2024 era. Well, there are many differences between both cars. However, the biggest one is the absence of a heat pump in the legacy model. This car uses resistive heaters, which theoretically should be way less efficient when it comes to heating compared to this car right here. In this video, we're gonna see which car is gonna reach to 24 degrees Celsius, which is about 75 degrees Fahrenheit quicker. And we're also gonna be tracking how much energy both cars are gonna be using during that process. To keep things fair, we left both cars outdoors overnight and their interior temperature is about 6 degrees Celsius, while the outdoor temperature is 3 degrees currently. And looking at the battery management system, I can tell you that the legacy Model 3 has 55% state of charge, equivalent to 38.2 kilowatt hours, while the Highlander sits at 59% state of charge with 35.9 kilowatt hours available. Let's put the heat settings at maximum level, start the timer, and also we're going to be using digital thermometers in both vehicles to see which one will reach the target temperature faster. While the test is on, I want to quickly mention that we will be running all kinds of experiments during this winter season with our cars. So if you enjoy this type of content, consider subscribing to our channel. After about 20 minutes, the test is concluded and both cars have reached their target temperature. The legacy model reached it in 19 minutes, consuming 1.5 kilowatt hours of energy, while the Highland model got there in just 11 minutes and used 1.3 kilowatt hours, which is 15% less. With this test, we were able to prove not only that the heat pump on the Highland Model 3 is way more efficient than the resistive heaters on the legacy models, but also that it's able to do the job way quicker, 72% quicker to be exact. And by the way, this result was done stationary. Tesla is claiming that this car right here is going to be 20% more efficient if it's in motion. Because how the heat pump system works, if the car stays in one spot, it captures the cold air, pulls the warmth out of it, runs it through a compressor, and then shoots it back into the cabin at a higher degree. However, when it's in motion, it captures the heat produced from the motors and the battery, and then runs it straight into the cabin, which should be more efficient than the legacy model. And the way the legacy model works is it's using the resistive heaters, and those resistive heaters are not capturing any warmth from anywhere outside the car. It actually produces it from scratch, which makes it more inefficient. And as you saw in this video, it took it 19 minutes compared to the 11 on the Highland model. If you are a legacy Model 3 owner and it's time for you to upgrade your vehicle, do you think these results are enough for you to pull the trigger and get the Highland model? Let me know down in the comments of this video. And I'm gonna see you next week with another comparison one.